Today I am going to talk about Taylor's method for solving ordinary differential equation. Given differential equation here, that is dy by dx is equal to 2y plus 3 e to the power x. So we have to solve using Taylor's method up to second order term. So here initial condition is given y at x is equal to 0, that is 0. And we have to find out y at x is equal to 0.2. At x is equal to 0.2, we have to find out y. So now here is the general Taylor series expansion. So at x is equal to 0, Taylor series expansion is yx plus h is equal to yx plus h into y dash x plus h square by 2 y double dash x plus higher order term. For small h, higher order terms are neglected. So we have to take up to second order term and find out what will be the y at x is equal to 0.2. Now given ODE, that is dy by dx means y dash x, that is 2y plus 3 e to the power x, that is given. At x is equal to 0, y at 0, that is also 0, that is also given. So at y dash at x is equal to 0, so that is if we plug that x and y value, so 2 into 0 plus 3 into e to the power 0, so that will give 3. Next we have to do the differentiation with respect to x, so we will get y double dash x means d square y by dx square is equal to y double dash x is equal to d by dx 2y plus 3 e to the power x. Now here since dy by dx is 2y plus 3 to the power x, so differentiate both sides, so we'll get y double dash x is equal to, so if we do that differentiation, so that will give 2y dash plus 3 into e to the power x. So now at x is equal to 0, we'll get that double derivative y double dash at x is equal to 0, so we'll get 2 into 3, so we already got y dash at 0 is equal to 3. We plug that and then these 3 into e to the power 0, so we'll get 6 plus 3, that is 9. So after getting y dash 0, y double dash at x is equal to 0, also we got that 2 value, and after getting that 2 value we plug that and we'll get that y x is equal to 0.2, what will be the y value. So y 0.2, that y 0 plus h y dash 0 plus h square by 2 y double dash 0. So here h is 0.2. So if I take h is equal to 0.2, then we have to plug, and we know that y0 is equal to 0, y dash 0 is equal to 3, and y double dash 0 is equal to 9. After plugging all these values, so y0 is 0, then h is 0.2, y double dash is 3, then h square by 2, that is 0.2 whole square by 2, and y double dash 0 is 9. So after doing that, after plugging, so we can calculate the value. So we'll get y 0.2, that is 0.6 plus 0.04 by 2 into 9 is equal to, that is 0.6 plus 0.18, that is 0.78. So at x is equal to 0.2, y will be 0.78. So that is the solution. So approximate solution using Taylor method, the approximate value is y 0.2, that is 0.78. That's it. Thank you.